All right, in this lesson, let's walk through an end-to-end model build. The great part about Python and SciKit-Learn is that in about 12 to 15 lines of code, we can create a model end-to-end that brings in the data set and then makes a prediction. In the next lesson, we'll walk through every line of code. But right now, let's go ahead and just knock out a model end-to-end. So we need from what? This is what we've seen in the previous lesson. Import data sets. So import data sets. Scikit-Learn has some data sets that we'll use for learning, and that's what the data sets is. We can import it, and we don't have to import it from a URL or bring it in from a CSV. It's baked into Scikit-Learn, which we get when we installed Python via Continuum Analytics. All right, so SVC is a support vectors classifier. More on that later. And it is called an SVM. All right, so it's a support vectors machine, but everything inside of Scikit-Learn is called a classifier. All right, all the models are classifiers, so let's remember that. No model name Scikit-Learn's, right? There is not. Control Enter. There we go. Let's add another cell. Let's go ahead and load that data set. So data set equals data sets. Now this is the one that's built in, right? Dot load underscore iris. Just a function to load that data set so we can work with it. Let's add another cell. Let's go ahead and create the model, or actually we don't have to create the model. What we're doing is using the pre-built model that's in Scikit-Learn, right? It's that one we just imported, and it's called an SVC, right? Now we need to fit the model to our data. Right? We need to tell the model, hey, this is our data. Can you act on it? Model dot fit ds data ds target. We have to tell what the target is. Remember our target variable in earlier discussions in the course. That's what that is. Let's print out the model. All models have some additional information that we can use to tune if we'd like. All right, so here is the SVC, support vector classifier model, right? And here is some additional information about that model. Again, not for this class. We need expected. What's the expected? Equals ds dot target. All right. And what the predicted? What's the predicted? Equals model dot fit the predicted data. Model dot predict the ds data, and then we want to print out the metrics about the model. Metrics tell us how well the model did. And as you can tell, I am not the world's best speller. And there we have it. That's it. So in this code, we imported some things that we want to use from sklearn. We imported our data set because, right, this is a supervised learning model and we need to point data at it. We've created this thing called a support vectors classifier. We fit it to our data. We've printed out some additional information about the model. We did it in expected and predicted to compare, and we printed out the metrics of the model. And as you can see, this thing here, again, we're going to talk about that whole bottom row in the next lecture, but precision is something you're going to see often. How accurate is the model? And it says here on the very bottom, it is 99% accurate in predicting what's inside the iris data set. And we'll talk again about what it was trying to predict, or actually what it predicted quite accurately according to our model. in the next lesson.